and allow me to help you discover some interesting facts today and make science learning quick and easy. Hello everyone! If you were given an orange juice, an acid, and a soap water base in two different glasses, will you be able to list the difference between the two? Perhaps the list will begin with different color, appearance, and so on. But these are just properties that we can see. Are these the only difference? Definitely, there are more. Orange juice tastes very sour. Soap water tastes slightly bitter. Yes, please don't try to taste it, just trust me. It tastes slightly bitter. Is this the major difference between the two? Yes! Taste is an important parameter to determine an acid or a base. Taste takes us to the chemical properties of a substance. Why does calamansi juice taste sour? Why does soap taste bitter? Any idea? Do you know what an acid is? Or what a base is? Let us get to know the terms first. To begin with, we have acids. The moment we hear the term acid, something scary or something that would burn the surface is what pops into our mind. Well, that's true. Because acids are known to create the burning effect, and whatever comes in contact with them, they can erode the surface or burn the skin. That's how acids are. The term acid comes from the Latin word acidus, which means sour. So, are all acids sour to taste? Yes, they are. Intensity of sourness may vary in different acids, but the overall taste of acids is always sour. The best examples of substances that contain citric acid are calamansi, oranges, and lemon, citrus fruits. Likewise, acids have different characteristics. It tastes sour. It reacts with bases to form salt and water. It conducts electricity. How will I know if the substance is an acid? I will give you some tips. If you have substance, like the citrus fruits mentioned earlier, and put some drop of it in blue litmus paper, and the litmus paper turns to red, that substance is an acid. Acid changes the color of the litmus paper from blue to red. Isn't it fascinating? You can also look at the chemical formula of the substance to determine if it is an acid or not. Most acids contain H or hydrogen at the beginning of the chemical formula. On the other hand, organic acids have carbon and hydrogen, or CH. For us to understand this better, let us take some examples. Here are inorganic acids in our surroundings. Remember, they have hydrogen. We have carbonated drinks or soft drinks. These have carbonic acid, which has a chemical formula H2CO3. Did you notice that there is H in the beginning? Next, we have hydrochloric acid, HCl, which is used as toilet bowl cleaner and for cleaning metal surface. It has a formula HCl. Have you noticed the H in the beginning? Next, another inorganic acid is nitric acid. It is used for making fertilizers and explosives. If you can observe, its chemical formula is HNO3. Now, let us proceed with organic acids in our surroundings. The clue here is that it has CH, carbon, and hydrogen. It has CH in the start of the chemical formula. We have vinegar. It contains acetic acid, which has a chemical formula C2H4O2. It contains carbon and hydrogen. Another example is ascorbic acid. It is one of the components of the vitamins to have a stronger immune system. Ascorbic acid has a chemical formula C6H8O6. Next is the citrus fruit, like lemon. It contains citric acid, an organic acid which is used as flavor for drinks and used as preservatives. Its chemical formula is C6H8O7. Now, we were through with acids. Let us go with bases. Bases are bitter, slippery, and soapy. They are also react with acids to form salt and water. How will I know if the substance is base? If you have a base, like ammonia, just use a red litmus paper, and if the red litmus paper turns to blue, that substance is base. Or, you can also look at the chemical formula. Most bases end in OH or hydroxide. Here are the examples of the bases in our surroundings. First, we have antacid, a medicine against hyperacidity. An antacid is made up of aluminum hydroxide. It is also used in color cast fabrics and water purification. AlOH3. You can notice it has OH in the end. We also have leather. Leather has calcium hydroxide. Calcium hydroxide is used for leather making, and it lessens the acidity of the soil. Let us check the chemical formula. CaOH2. Another example of base is soap or soft soap. What is the base in it? We have potassium hydroxide. Potassium hydroxide is used in making soaps, fertilizers, herbicides, and pesticides. What is its chemical formula? It is KOH. So, what's next? So we have detergents or laundry soap. It contains sodium hydroxide. It is used in making soap, detergent, textiles, and even drain cleaners. It is commonly used as cleaning agent at home. So what is its chemical formula? It is NaOH. Next example is fertilizer. So what does it contain? It contains ammonia. Ammonia is also a base. But let us try to check the chemical formula of ammonia. It is NH3. This was acids and bases in general. Now, can you tell me what will happen if an acid is added to a base? Will the solution explode? Will it give an expected reaction or something else? Well, it is something we already know. Imagine, we mix a strong acid, hydrochloric acid, with a strong base, sodium hydroxide. What will be the result then? The reaction yields NaCl, or sodium chloride, and water, H2O. Sodium chloride is common salt used by us. So, acids with a base gives us salt and water. This is a general reaction. Salts are products of reaction between an acid and a base. But now, if you were given a concentrated sulfuric acid, how are we supposed to know the nature of that acid? So, we need to use an indicator. Substances are used to check whether the compound is acidic or basic. The indicator indicates by changing their colors. Indicators when added with acids and bases changes in color. That becomes convenient for us